Let's talk about the LNG storage. The LNG is stored at minus 260 degrees, which this engine requires liquefied natural gas as it stores fuel. What we have inside this tank is a dual wall cylinder. There's a vessel inside a vessel. The inner vessel holds the liquid at minus 260 degrees. It's surrounded by a vacuum. We pull a vacuum, and then the exterior shell is 1/4-inch stainless steel, which makes it an extremely safe tank. The reason we pull the vacuum is to prevent the ambient temperature, whether it be 140 degrees in the desert or minus 40 degrees in the north of Canada, to impact that fuel inside the tank. Inside the tank we have an LNG pump. That LNG pump draws up a volume of fluid. We compress it to high pressure. This engine requires 4,500 psi to run. Compressed natural gas in its standard state is 3,600 psi. So we compress the liquid to high pressure, bring it up to the back of the shroud, where we vaporize it right here using the coolant from the engine. The coolant from the engine at 104 degrees instantaneously vaporizes that LNG to high pressure compressed natural gas. That gas then flows forward to what we call an accumulator. It's actually a buffer to the engine. It's located on the frame rail, right about here. It stores 9 cubic feet of high pressure compressed natural gas at 4,500 psi. It services as our buffer so that we are constantly sending 4,500 psi up to our fuel conditioning module. The fuel conditioning module does two things. It meters the pressure of the natural gas and it meters the pressure of the diesel. So we also have to add a high pressure diesel pump to bump the diesel pressure up to 4,500 psi. Our system uses a patented injector that delivers both the diesel and the natural gas through the same injector combustion chamber. So we have to have the same pressure fuel on both sides, diesel and natural gas, so that we don't get backflow of any fuel in either direction. Back to the fuel conditioning module. Not only does it meter the pressures going into the cylinder, into the injectors, but it also takes information from the throttle position sensor, the air pressure and ambient temperature sensors, and various sensors throughout the engine to determine what the actual load is going to be delivered into the engine. At full load, we require 4,500 psi. At idle, we require 2,200 psi. So if your driver's driving down the road, he's doing 1,600 RPM, he's only using about 40% of the load, it will reduce the 4,500 psi to the injectors down to about 3,000 psi. And that way we'll maintain that load requirement.